Hello everyone, welcome back. Let's talk about another medium problem on LeetCode today. Construct string with repeat limit, LeetCode 2182. In this problem, we are given string s and an integer repeat limit, and we have to construct a new string, repeatLimitedString, using the characters of s such that no letter appears more than the repeat limit times in a row. We do not have to use all the characters from s, and in the end, we have to return the lexicographically largest repeat limited string possible. Just as a note, a string A is lexicographically larger than string B if at the first position where they differ or they have a mismatch, the character in A appears later in the alphabet list than the character in B. Or if they don't have a mismatch, then the longer string is considered larger. For example, suppose the given string s1 is abc and string s2 is aba. Now which one of them is lexicographically larger? And the answer is s1, because both the strings are identical up to second character, but at the third character where they differ for the first time, the letter in s1 is c and letter in s2 is a, and c comes after a in the alphabet list. So s1 is lexicographically larger than s2. Now consider the example where S1 is AC and S2 is ABA again. Now which one of them is larger? Again it is S1, because even though S2 is longer than S1, the first character they differ at is at the second position. In S1 it is C and in S2 it is B, and we know that C occurs later in the alphabet list. So that's why S1 is lexicographically larger than S2. And finally, let's look at the last example. Now suppose S1 is AB and S2 is again ABA. Now which one is larger? And this time it will be S2, because S1 is prefix of S2. That is, all the characters of S1 match with all the characters of S2 and there is no mismatch. So the longer string S2 is lexicographically larger than S1. Now coming to the example, for the given string, we can see that C occurs 4 times, A occurs, Z occurs 2 times and A occurs once, and the repeat limit given to us is 3, and the largest character to form the lexicographically largest string will be Z here. So we take 2 Z's, and now we have consumed all of the Z's. Then the next lexicographically largest character will be C, and we have 4 of it, but the repeat limit is 3. So we will append 3 C's to the answer string. So now we still have 1 C remaining. Then only available character apart from C is A. So we append it to the result string. And now we have no A remaining. And finally, we append the last remaining C to the result. And this will be our longest lexicographical string for the given string with repeat limit equal to 3. Now our goal is to construct the lexicographically largest string possible with the constraint that no characters repeat more than repeat limit times consecutively. And if our task was to just create the lexicographically largest string without any constraints, then we could have just sorted the characters in the string in the reverse alphabetical order, and that would have just taken O of n time, because we would just create a frequency map to count the occurrences of each character in the string and then iterate over the characters from Z to A in the reverse alphabetical order and append each character in the result as many times as they appear in the frequency map. This is similar to performing like a bucket sort. However, the catch in this problem is repeat limit, which prohibits any character from appearing more than the specified limit consecutively. So then how should we approach it? Again, the idea can be that we create a frequency map because we need to know how many characters we want to append to the result. So for example, in the given string, C appears 4 times, Z appears twice, and A appears once. Then we pick up the lexicographically largest character. In this case, it will be Z, for example, and append it to the result as many times as possible such that it doesn't exceed the repeat limit. So in this case, Z is already under repeat limit, so it is not a problem. We can just append it to the result. And as we are appending the characters again and again to the result string, it is better to use mutable string implementations like string builder in Java or a list of characters in Python. This avoids the inefficiency which may result if we use a default immutable string implementation in the respective programming languages, as it creates a new string every time we append a character. Now we have used all the Z's, and we will repeat the same process for the remaining characters in the frequency map. So now we will again pick up the lexicographically largest character, and this time it will be C. And we can pick it up as many times as possible such that it doesn't exceed the repeat limit. So we pick up 3 C's because repeat limit is equal to 3. And now that we have appended C up to the repeat limit, we need to switch to the next largest available character to break the sequence. And in this case, the next largest character is A, but suppose we also had B with frequency 1. Then we would have chosen B over A because we want to form the lexicographically largest string, right? But let's remove it to keep the example simple. And how many of these characters should we take? Here A's availability was only 1, but suppose we had 2 A's available instead of 1. Then how many A's should we have taken? And the answer is still 1. Because our primary goal is to break the sequence and resume appending the larger character as soon as possible, so that we form the largest lexicographical string with given constraints. For example, suppose we had 5 C's and 2 A's and repeat limit was 3. Then which of the strings will be lexicographically larger? This one where we had 3 C's, then 2 A's and then 2 C's, or this one where we append 3 C's, break the sequence with one character of A and append 2 C's again and then A. And the answer is this one, because when the first mismatch occurs, the character C is larger than character A, and hence second string is lexicographically larger than first one. So that's why we need to append one character of the next largest character possible to break the sequence. And once the sequence is broken, we return to appending the previous character if there are remaining instances of it. Now coming back to our example, let's again keep it simple and keep the frequency of A as 1. So we append A to the result to break the sequence of C, and now we have consumed all the A's and we again return back to the previous character which was C. We still have one C remaining, so we append it to the answer string. And now we are done with all the characters and this will be our answer. And just one last point, notice that we were picking up the largest character again and again, and which data structure can help us here? And the answer you would have already guessed, it is maxheap. Because with maxheap, it takes O of log n time to extract the largest element and add the element to the heap, where n is number of elements in the heap. So with frequency map in hand, we can build a max heap where we will store all the characters that are present in the input string, that is the characters for which frequency is not 0. And then we can pull out the lexicographically largest character from the max heap, append the character to the result string such that it doesn't exceed the repeat limit, and if it does, break the sequence by appending next lexicographically largest available character. And whenever we append the character, we also reduce the count of it in the frequency map. And continue this process until all the characters are processed. Now let's jump into the code part. First, let's create the frequency map. And for that, we can use array of size 26 because in the constraint it is given that string S contains only lowercase English letters. Then we can go through each character in the given string and update the frequency array. And we can get the correct index of the character in the frequency array by subtracting letter A from the character. For example, if the character was A, then A minus A will give us 0. Similarly, if character was B, then B minus A will give us 1 and so on. And then we increment the count for that character at that index. Then we will create a max heap to store characters in descending order. And in Java, we can use priority queue implementation to do that. And because it's a max heap, we will pass in the comparator in the reverse order. Now we will add all the characters present in the existing string to the max heap, that is frequency of the character is more than 0. And one way we can create the characters is by looping on the numbers 0 till 25 and adding the letter A to those numbers. Let's also create answer string, and we will use mutable string implementation called string builder in Java to do that. And now we will start processing all the characters in the max heap. We pull out the lexicographically largest character from the max heap and check number of times it can be appended to the answer string, and it will be equal to minimum of its frequency or the repeat limit. Let's call it count. Now we append current character count number of times and decrement the count frequency from the frequency map for the current character. And if we still have this current character available, that is we still have frequency of this character more than 0, then we have to break the sequence. For that, we have to pull out the next largest character. But before that, we should check if the heap is empty. If it is, then we are done. So we will break out of the loop. Otherwise, we pull out next largest character from the heap and append it to the answer to break the sequence. And now we will reduce the frequency of this character by 1 If the frequency of this character is still greater than 0, that means we should add it back to the heap so that we can process it in the later iterations. We will also add current character back to the heap so that we can process it in the next iteration. And once we are done with all the elements in the heap, we will return the answer by converting the string builder back to string. Now let's submit this code. Cool. In terms of time complexity, it will be O of n plus n log k, where n is the length of the input string and k is equal to 26. That is number of lowercase characters we are dealing with. And the reason for this is, first we are going through all the characters in the input string and building the frequency map. And then we are going through each element in the max heap, and max heap at maximum will contain 26 characters. So because of this, extracting maximum element or adding back the element to the max heap takes log k time, which is constant, and the combination of the outer loop and the inner loop up till count will result in time complexity of O of n in the worst case. So because of this, the time complexity of this loop is O of n log k, and log k is again constant. So because of this, that overall time complexity stays O of n. And in terms of space complexity, it will be O of n, because for the frequency array and max heap, the space complexity is O of k, which is constant. But for the result or answer string, the space complexity is O of n, because in the worst case, it will be proportional to the length of the input string. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.